Hey ladies and gentlemen, it's Mr. Anderson again. Today we're going to talk section 2.3.1 out of our CP/M algebra book, and we are going to talk about something we know, which is slope-intercept form of a line, and we're going to talk about how useful it can be, but also some limitations that it had. Let's revisit real quick where we're at. As we left the last section, we talked about the big race. We had to find the equations with a slope and maybe through a given point or an intercept. Well, today that point isn't necessarily going to be that intercept, and we're going to talk about the restrictions that puts on us. And we start to develop some of these algebraic skills and some of these manipulation skills that allow for us to do some solving as well as some more advanced calculations and well, modeling, which is what we're going to have here. We start with 2-75 out of your book. I did modify this slightly so it doesn't look exactly like it would in your book, but for the most part, everything is going to be the same. Colleen recently purchased a farm that raises chickens. She has never raised chickens before. Colleen wants to learn as much as possible about her baby chicks. In particular, she wants to know how much a baby chick weighs when it is hatched. Okay, so she's got a little bit of information. She doesn't necessarily know the birth weight of a baby chick, but she's interested in that. So to find out, she decides to track the weight of one of those chicks that was born just before she purchased the farm. She finds out that it grew steadily by about 5.2 grams each day. Anytime we're given a this per that, grams each day or grams per day, that right there, ladies and gents, is going to be our slope. So this is worth taking special note of. This 5.2 grams per day is going to be our slope. Then she assumes it's been growing this way or doing this since it's hatched. That is steady growth rate, which means that we can assume that Colleen's model is linear and that slope is going to continue for days 10, 11, etc., but it'll also continue backwards in time, and we're going to need those two ideas and skills. All right, 9 days after it hatched, the chick weighed 98.4 grams. So I've taken that little tidbit of info and I've graphed it right here on just a coordinate plane. I took 9 days, I let X be my time, I let Y be my weight. 9 days later, 98.4 grams. Okay, now here's our job. All right, we're going to determine how much the chick weighed the day it was hatched using two different representations of the growth. We're going to talk about the graphical representation, but then we're going to talk about the table representation. We're going to talk about pros and cons of each. We're going to talk about limitations, and then we're going to move on, maybe using something a little bit more advantageous. So here's the way I would start, okay? I plotted this point. The chick was 9. Real quick, let me point this out. My scale on the y-axis is 10, like from 80 to 90 and 90 to 100. Those are 10s. My steps are 10s. So when I am talking about the growth rate of this chick, I can go, if I go from here to here in my slope triangle, that would be like a move of 10, and 5.2 is approximately going to be half that. So in this particular case, a chick on day 9 weighing 98.4 grams, on day 10, somewhere over here, would weigh 98.4 plus 5.2. 98.4 grams plus 5.2. I'm going to erase this math here in just a moment, but I can do that. Let's see. Let's see, that's going to be a 103, right? 103.7. Oh, I copied wrong. That's going to make that, and that's going to make that a 6. So 103.6. So 103.6, let's see, that's going to be somewhere, I'm estimating, it's going to be somewhere right about there. Okay, so I've got another dot there, and now I've got enough information to make a line. And if I zoom out, we can see that stretching a line through those two things would give me a decent little model, but it's not going to be perfect. And this is going to be a limitation of graphing. Maybe you can estimate that I'd have another point right about there, and maybe there would be another one right about there, and so on and so forth. And watch what happens here, folks. All right, there we go. And now I'm going to go back this direction. And it's not perfect, but I think we did a pretty gosh darn good job. All right, I've got a line that stretches through those points, and you might say, hey, what about that point, Anderson? It's not perfect. Well, that's okay, because graphing, remember, especially in this kind of a case, is going to be an estimate, and unfortunately, we got to play the hand we're dealt. That's a limitation that we have. So check this out. All right, if our job is to estimate the birth weight of that chick, I'm going to go back here and I want to try to find the y-intercept. Now, if you are like me, you're looking at this thing and you're going, oh man, there is no way I can know exactly what that is. So I'm looking at that and I've got some question marks. All right, what do you think that is? What is that? Maybe 53 grams? Right? Maybe that's 53 grams. I'm not sure what that y-intercept is. But we estimated. We got close. And during situations when you only need an estimate, graphing might work really, really well. So it went quick, right? It didn't take us too long to do that. But we couldn't be perfect, okay? Check out an alternative method for that, okay? I've got a table. Okay, now I set this table up ahead of time. I've got X representing my days. I've got Y representing my birth weight. And right here, you guys can, or excuse me, the weight of the chicken grams, not birth weight. All right, you can see right there, I got that same point, 9 and 98.4. And I can go ahead and do math, and I can try to figure out what that birth weight is, right? That birth weight is way down here. And here's how some of that works, right? If I took 98.4 and I added 5.2, because that's how much that chicken's growing per day. I think we said a moment ago that was going to be 103.6. And I could add another 5.2, and that would be 108.8. And I could add another 5.2, and that would be, let's see, 114, etc., etc. And I could keep going. All right, I could keep going on day 13 and 14 and so on. And I could work backwards. And I could, instead of moving to the right and adding 5.2, I could subtract 5.2. So this would be 2, this would be 3, this would be 9. That would be 93.2. I could subtract 5.2 again. Let's see, 0, 8, 7, 8, 88.0. I could subtract 5.2 one more time. See, 8, borrow 7, right? 82.8, right? And you guys can see that I can work backwards, subtracting 5.2 every single time until I get to here to figure out that birth weight. But just like graphing, that limitation is going to be in the, it's going to be inefficient, okay? There's going to be a lot of opportunity for error. By adding or subtracting 5.2 every single time. It just may not be the best method. Maybe there is a better way, and that's what this next problem is going to shine a light on for us. It's going to be some algebra that is going to make your life easier. Fast forward with me, folks, to number 78, and we're going to come back and we're going to see if we can get that birth weight correct. Check it out. All right. Now we're going to explore another way that Colleen could find the weight of her chicken when it hatched without using that table or graph. And we're going to revisit the equation in slope-intercept form, right? Check this out. Since Colleen is assuming the chick grows linearly, right? It's a steady growth rate. The equation in y equals mx plus b form is going to be helpful. We know that that slope is 5.2. We know that the intercept, the b, is going to be the birth weight. But the only one of those things that we know is 5.2. We know that the growth rate is 5.2, but we don't know what b is. All right, and that's what we're going to try to figure out. So let's go ahead, let's do some substituting, and let's do a little bit of algebra and see if we can get there. All right, we already know the chicken's growth rate, and we're going to put this into the equation. So I started, check this out, I started with y equals mx plus b, right? And then I traded out the m for the known slope. So from here to here, the only thing I did was I said, all right, well, let's see, replace m, 5.2. B, though, folks, is still up in the air. B is still a question mark. So unfortunately, I'm going to have to leave B in. right? And you might say, well, why, Anderson? Why? We don't know it, and I'm going to add to that, we don't know it yet, all right? We're going to figure out what it is. We're going to have a way, a very systematic way to do it in just a moment, but we just don't know it yet, okay? Let's revisit the other piece of information that we're given because we haven't necessarily used that yet, okay? We have a point that they generously gave us in this problem. They generously gave us the point 998.4, right? That was after 9 days, the chick weighed 98.4 grams. And we can use this to help us find the y-intercept because that point is an xy coordinate. The 9 is x number of days. The 98.4 is y grams. And we can substitute and use our algebra skills in order to be able to solve. And this is actually pretty easy. You guys have done this before. Watch, let me show you. All right, I took this, I stripped out the x and the y, and for the x, I will put in our number of days. And for the y, I will put in our 98.4. And b, remember, is the thing we're finding. So I'm going to leave b in there. Now, this is going to require just a tiny, tiny bit of arithmetic. Okay? And I'm going to show my work. I'm going to rewrite. That way you guys can do this on your papers as well. I've got my handy-dandy iPhone here. And on my iPhone, I have this thing that you guys probably all have. One of these guys, right? First thing I'm going to figure out is what is 5.2 times 9. I can't do that in my head, so I rely on some accurate technology here. I'm going to rewrite, I'm going to rewrite, and I can say that 98.4 is the same thing as, instead of 5.2 times 9, I'm going to call that 46.8 plus b. All right? Now is when we have to use that the algebra skills. Now we've got to solve a one-step equation by subtracting 46.8 from both sides. And again, cancel, right? This is work from the appendix, and I'm just going to take a second to make sure I have this thing correct. So 98.4, and then let's see, minus 46.8, 51.6. Now, is that reasonable, right? Is our y-intercept reasonable? Does that match algebraically? I'm moving on to E now. Does that match algebraically what we found on the graph? Well, on the graph, we estimated that to be around 53. 51.6 isn't that far off. We're pretty gosh darn close. Does it match the one we found using the table? You know what? We ran out of steam before we got to the table. All right, we ran out of steam. You guys go back and check. I'm physically exhausted. I didn't do that, but I'm going to show you another way we can check and see if we're accurate. Check this out. I'm just going to rewrite this equation one time. Y equals 5.2x plus, but now instead of writing b, I'm going to write 51.6, that birth weight or that hatching weight of that chicken. And we're going to do something a little goofy here. You guys ready? I'm going to take this equation, our model that we think is accurate, and instead of writing x, I'm going to use our known data. Okay? Check this out. I'm going to see if this works. We were told that after 9 days, that chick weighs 98.4 pounds. So I've got my calculator again. Okay? I'm going to just go ahead and evaluate this. 5.2 times 9 plus 51.6. And if I've entered this correctly and I've done my work correctly and I hit equals here, I should get 98.4. Oh, try to show it to the screen there. And you guys can see that. I definitely do. Right? Ladies and gents, thanks for your attention here. Okay? You are welcome to go back. You can rewatch. You can pause and start and stop any of the parts here. But folks, that is how we take a slope and a point and find the equation of a line. Okay? We've got a little bit of review preview. It's questions number 82 to 85. Try everything. Check your answers. Email if you have questions. Ladies and gentlemen, thank you for watching. Have a great